Hello everyone, welcome to my YouTube channel. Today I am going to explain the topic of Introduction to CNC, Advantages and Applications of CNC and 3D Printing. Introduction. Manufacturing complex curves, geometrics in 2D or 3D was extremely expensive by mechanical means, which usually would require complex jigs to control the cutter motions. Machine components with repeatable accuracy, complicated shape machining. CNC, computer numerical control machines, are automated machines which uses programs G and M codes to automatically execute series of machining operations. CNC stands for Computer Numerical Control. It is manufacturing process that utilizes computerized system to control machine tools. CNC machines are capable of producing complex and high accuracy. CAD, Computer Aided Design, and CAM, Computer Aided Manufacturing programs are used in modern CNC machines for component design and manufacturing. History. In 1947, MIT developed numerically controlled machine for US Air Force. 1952, prototype NC machine demonstrated punched tape input. In 1980, CNC machine computer used to link directly to controller. In 1990, DNC external computer drip feeds control programmer to machine tool to controller. The concept of CNC originated in the late 1940s. The first CNC machine was developed by John T. Parsons and Frank L. Stulin in the 1950s. CNC technology has evolved significantly over the years, leading to more advanced and efficient machines. Definition. Computer numerical control or CNC is an advanced form of the NC system where the machine control unit is a dedicated microcomputer instead of a hardwired controller as an conventional NC. Computer numerical control has evolved during the rapid improvements of the computer technology. The advent of microprocessor from 1970s have helped in a quick advancements in the computer technology and is in turn adapted in modern CNC technology. Today's CNC controller has latest features like high speeds of operations, large memories, bus architectures, improved servers, and etc. CNC technology has powered the machine tool industry today. Components of an CNC system. A CNC system consisting of the following elements: input device, MCU or machine control unit, machine tool, driving system, feedback devices, and display unit. The core components of a CNC system include the machine tool, the control unit, and the programming interface. The machine tool refers to the physical equipment that performs the cutting or shaping operations. The control unit consists of the computer and software that controls the machine's movement and operations. Types of CNC machines. CNC machines can be categorized into different types based on their applications, such as milling machines, lathes, routers, and 3D printers. Each type of CNC machine is designed for specific purpose and can perform different operations. CNC machines can be further classified as vertical or horizontal, depending on the orientation of the spindle. Following are the advantages of numerical control. Reduced non-productive time. Numerical control can increase the proportion of time the machine is engaged in the actual processes. It accomplishes this by means of fewer setups, less time in setting up, reduced workpiece handling time, automatic tool change on some machines, and so on. Reduced fluctuating NC requires fixtures, which are simpler and less costly to fabricate because the positioning is done by the NC tape rather than the jig or fixture. Reduced manufacturing lead time because jobs can be set up more quickly with NC and fewer setups are generally required with NC. The lead time to deliver a job to the customer is reduced. Greater manufacturing flexibility. With numerical control, it is less difficult to adapt to engineering design changes, alterations of the production schedule, changeovers in jobs for rush orders, improved quality control. NC is ideal for complicated work parts where the chances of human mistakes are high. Numerical control produces parts with greater accuracy, reduced scrap and lower inspection requirements, reduced inventory. Owing to fewer setups and shorter lead times with numerical control, the amount of inventory carried by the company is reduced. Reduced floor space requirements. Since one NC machine center can often accomplish the production of several conventional machines, the amount of floor space required in an NC shop is usually less than in a conventional shop. Disadvantages. Higher investment cost and numerical control machine tools represent a more sophisticated and complex technology. This technology cost more to buy than its non-AC counterpart. Due to higher cost max, machine utilization is essential. Higher maintenance cost. Because NC is more complex technology and because NC machines are used harder, the maintenance problem becomes more acute. Finding or training NC personnel. Certain aspects of numerical control shop operations require a higher skill level than conventional operations. Part programmers and NC maintenance personnel are two skill areas where available personnel are in short supply. The problem of finding, hiring and training these people must be considered a disadvantage to the NC shop. Applications of CNC. Machine tool applications: milling, drilling, turning, grinding, boring, punch presses, EDM profile cutter, laser cutting machine. Other applications: component insertion machine in electronics, drafting machines, XY plotters, coordinating measuring machine CMM, tape laying machine for polymer composites, filament. Introduction to 3D printing. 3D printing is processes where a digital model created using computer-aided design software CAD is turned into a physical three-dimensional object by adding material a layer at a time. 3D printing is also known as additive manufacturing because materials is added during the process of manufacturing to form the object. The opposite of this, known as subtractive manufacturing, is where material is cut away from the sheet or a block of material to form the object. For example, manufacturing processes such as milling or laser cutting. Additive manufacturing waste, where little material compared to subtractive manufacturing. The way that 3D printing forms an object in layers allow for objects to be created. Advantages. Setting up the production system is simpler because it involves fewer stages. Such wouldn't be a need to store inventory in frames. Assembling products can be simultaneous process to production. Layer by layer production allows for much greater flexibility and creativity in the design processes. Parts can be completely redesigned so that they are stronger in the areas that they need to be and lighter overall. 3D printing significantly speeds up the design and prototyping process. Limitations of 3D printing. Expensive hardware and expensive material. This leads to expensive parts, thus making it harder if you 3D printing is not the answer to every type of production method. Another major disadvantage of 3D printing is that the highly capable printers may potentially replace highly skilled workers, shifting entire companies and countries to people-less production. Thank you.